Welcome to our notes on functions, domain, and range. Students will be able to identify if a relation is also a function and identify its domain and range. So task 1 is an in-class activity, people and birthdays, but I'll preview it for you now. I will ask that you ask a few peers what month they were born in and record in the table below. So you're going to make sure you ask their name and record their birth month below. In class, we will explain what this table is going to be and what those headers ought to be. But then we're going to explore whether or not the name of the person or the birth month should be the input so that the output is consistent. Task 2, key vocabulary. What is a relation? A relation is a relationship between the inputs and the outputs. We can show a relation in various ways, such as a set of ordered pairs, a table of input and output values, or a graph. A function is a relation where every input has only one output. And lastly, the vertical line test is a visual test to determine if a graphed relation is a function or not. Task 3, which is a function? Example 1 or example 2. So let's first look at a set of ordered pairs. These squiggles, these brackets here, literally means the set of. That's how I would say it, the set of, and all of what's inside are ordered pairs. So this literally says the set of ordered pairs. Okay, so in order to determine if something is a function, I need to make sure that every input has only one output. So I look at the input of 1, I'm good because I have no other inputs of 1. I look at the input of 2, but there's also a 2 here. So I need to check their outputs. This is a -2 and this is a +4. Those are different outputs. So this one input of 2 has 2 different outputs. So I can tell because of this situation here that I don't have a function because this input of 2 has 2 different outputs. I need only one. Okay, similarly, I can look at x equals 4, same thing. -6 and 6 are not the same outputs. So that's another reason why this isn't a function. And lastly, I can look at 5. The input of 5 goes to 2 different outputs as well. So this is not a function. Let's look at the table of values. So all of these ordered pairs are put into this table of inputs and outputs. Now, typically for input, we call this X, and for output, we call this Y. It is not always X, nor is it always Y, but those are the most common, right? So I just plotted all of these ordered pairs into the table. So 1, 2 is this ordered pair here. 2, -2 is this one here, etc., etc. So we can see a little bit more clearly from the table that it's not a function. So remember, this is the reason why it's not a function. That's one reason why it's not a function. You could have also said, hey, this one, because those inputs, 2, 4, and lastly 5, have more than one output, so it's not a function. Now, here's the graphical representation of the table we just saw. I don't know if these are connected or not, so don't make a habit of connecting them unless you know it's a connected graph. So this is what we call a discrete graph, right? We're just plotting points here. So I'm going to use what's called the vertical line test to figure out whether or not this is a function. We already know that it is not, but let's just go ahead and do that. So I'm going to find a vertical line that intersects more than one point. Okay, so I'm going to draw one here. Okay, this intersects more than one point. This is at x equals 2. All right, and because it does that, I can tell it is not a function. I can also put a vertical line here at x equals 4, right? Remember, this one went to +6 as well as -6. So these are reasons why they're not functions. And lastly, I can put one at x equals 5. You only need to find one vertical line, just one, that will intersect more than one point at a time. Okay, so in this case, you have 3 options for determining whether or not this is a function. So now I'm back on the previous page, and we can confidently say that example 1 is not a function. Okay, let's look at example 2's set of ordered pairs. So I'm going to look first here. I'm going to look, here's the input of -8. I see no other -8, so I'm good. This input only has one output. -5, I don't see any other -5s. -2, I don't see any other -2s. 2, I don't see another 2. I don't see another 3, and I don't see another 5. So automatically we can say that this is a function because every input here has only one output. Let's look at the table of values. It represents the same set of ordered pairs. Again, our inputs are typically X and Y, not always, so be careful. And here I'm looking for any repeated input values because then that means I need to look for their outputs. I don't see any repeated values, so automatically this is a function. So remember in example 1, this was a repeated X value, so I had to then look at their outputs. Never assume that because it's a repeated input that automatically is not a function. You must look at their outputs to see if they are the same or if they are different, because if they are different, then you can conclude that they're not, that it's not representing a function. So here's a graphical representation of example 2. You are looking for a vertical line that will intersect in more than one place. So if I were to practice here, that only goes through 1, so not that one. That only goes through 1, not that one. Not that one, that only goes through 1. I'm looking for one that goes through 2 or more. Nope. Nope. And nope. So I can't find a vertical line that will intersect more than one of these points. And because of that, I can conclude that it is a function. So I'm going to go back to the previous page, and I'm going to confidently say that this is a function. Okay, so this is something that I want you to do. I want you to reflect on these 3 different representations of how functions can be shown or relations can be shown to determine whether or not they are functions. Remember, the definition is that every input has only one output. So if you have determined that every input has only one output, then you have concluded that that relation that you're looking into is a function. If you have determined that there is at least one input that has more than one output, then you have concluded that it is not a function. All right, so let's talk about domain and range. Domain is a list of all of the inputs of a relation, and the range is a list of all of the outputs of a relation. Okay, so from example 1, I'm just going to go ahead and show you. Because this was a discrete function, it wasn't a continuous thing, I'm just going to list all of the inputs. So the domain, I need to go ahead and make a bracket. And the first input was a 1. We had 2 2s, but I only need to write it once. We had 1 3. We had 2 4s, but I only need to write it once, and we had 2 5s. I only need to write it once, and then the bracket to close it. All right, for the range of example 1, so I'm gonna try to go in order, but even if you don't go in order, that's fine. So the lowest output was -6, and then we had -3, then we had -2. Let's see what comes next. 2 comes next. 3, 4, 5, 6. I think I got them all. Let me count. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Awesome. These are the list of all of the outputs. I put them in order. But for now, if you just wanted to list them, that's great. But putting them in order really helps us understand what is the lowest y value we can be, as well as what's the highest y value we can be. Same thing, what is the lowest x value we can be, and what is the highest x value we can be. All right, so let's do this quickly for example 2. The domain is the set of these x values here, -8, -5, -2, 2, 3, and 5. And the range is the set of these y values, -3, 2, 4, and 7. So remember, if it repeats, you do not have to write it twice. Just write it once and you'll be good to go. All right, so task 4 is practice. Analyze the relations below. Determine if each relation is a function and justify your answer. Find the domain and range of the relation. So, as an example, I'm going to do number 1. This is a more continuous type of graph. This is not a discrete graph. So our domain and range is going to change. It will look like inequality notation instead. So first things first, is this a function? Because I have a graph, I'm going to use the vertical line test to determine this. So I like to use red for this. And I can see if I just chose, I don't know, x equals 3, I can see clearly that this intersects the graph in more than one place. So there are 2 points that it goes through. So this is not a function. Okay, now we say that this fails the vertical line test. Okay, all right, not a function because it fails the vertical line test. But this is not enough. This is not the definition of a function. So you need to take that a little bit further. So what does it mean to fail the vertical line test? Which means there is at least one input. For example, x equals 3, that has more than one output. So if I look at x equals 3, x equals 3 goes to y equals -5 and y equals 3. So remember, this part right here, there is at least one input that has more than one output. Has to be a part of your explanation for why something is not a function. All right, so let's find the domain and range of this relation, of this graph. So the first thing I'm going to do is I'm going to take a highlighter and I'm going to highlight for the domain the lowest x value and the highest x value I can possibly be. So if I look, this has to be the lowest x value because here x is equal to 1 and I have nothing else that exists to the left of it. And the highest x value is 5 because nothing else exists to the right of that. So I'm going to take my highlighter and I can be equal to 1. So I'm going to put a closed circle there. I can be equal to 5. I'm going to put a closed circle here. And all of the x values in between I'm going to highlight because all of these x values will make up this part of the relation or this part of the relation. Okay, so I'm going to now write that in inequality notation here. So I'm starting with 1, that's the lowest x value I can be, less than or equal to, because remember I can be equal to 1, x, and x is less than or equal to 5. All right, so now let's look at the range. These are the y values that I can be equal to. So I'm going to take green this time. The lowest y value I can be equal to is -5. And the highest I can be equal to is a +3. And it's every y value in between because my graph has all of these y values. Okay, so I have all of these y values. So the way that I write that in inequality notation, we start from the bottom and we go to the top. So the lowest y value I can be equal to is -5. Less than or equal to y, because we're talking about y values, less than or equal to 3. And that's how we find the domain and range of this graph. All right, I'll do another graph example here. This is number 4. So because it's a graph, I want to use the vertical line test. I want to see if I can find a vertical line that will intersect this graph in more than one place. So if I draw one here, that's only one, so this vertical line is not going to show that it's not a function. That one either, in fact, there's no vertical line that I can draw that will go through this graph more than once. So this is a function because it passes the vertical line test. Now, you cannot leave your answer like that. What does passing the vertical line test mean? Always relate it back to the definition. You must have every input has only one output in your final response. So this is a function because it passes the vertical line test, which means every input has only one output. Let's find the domain and range now of this function. So it's important that we look at the ends of the graph. In this case, there's an arrow here and here. And this arrow is pointing in two directions. It's pointing up and it's pointing left. This arrow is pointing up and it's pointing right. So what does that mean? For domain, I care about most left to most right. So this left piece and this right piece is what I'm going to focus on as far as the way the arrow is pointing. So because I have an arrow pointing to the left, remember, if an arrow is pointing to the left, you're going to negative infinity there. And if it's pointing to the right, then you're going to positive infinity. So I can say something like this: negative infinity is less than x, which is less than positive infinity. Okay, remember, you can never put less than or equal to symbols because you can't equal infinity. It's not a number you can be equal to. It's a concept that says the numbers get large in those directions. All right, last but not least, when we focus on the range, we focus on the directions bottom and up, or bottom to top. So when it comes to the range, then I care about the fact that it's pointing up, these arrows. But the lowest y value that I can be equal to is -2. And because these arrows point up, I'm going all the way up with an arrow. Okay, so if I also went back to the domain, this whole number line would be highlighted. Okay, so the range starts at -2. Since I can be equal to it, I'm going to say less than or equal to y, and then I'm going to positive infinity. This is a positive infinity here, and this will be negative infinity. But since my arrow is not pointing down, I'm not going to negative infinity. So it's less than positive infinity. And that's how you write the domain and range in inequality notation.